So today we're going to look at how RapidCPT can now run directly in your web browser. So you log into rapidcpt.dataforensics.net in your web browser, assuming you have an account, and then you're ready to create a project. So let's create a project, give it a name, choose your office, whichever office it's in. Only users in your office will see this project by default. You choose your coordinate system. So I'm working in Georgia today. RapidCPT will do coordinate conversion. It will calculate lat longs from north and east, or north and east from lat long, depending on which you have in your data. Fill in whatever metadata you want. Cities and states. And if you want it to auto-calculate the centroid of your project based on your locations, it will. The calculation settings, this is populated by default for your organization, but you can change these on a project-by-project basis as needed. So whatever values you want to use in your analysis, you can set up here. You've now created the project and you're ready to import your data. So click the Import button. It's going to have you confirm, yes, you're working in the correct project. You want to import the data, and these are the settings you want to use. And then these units should be the units that you see inside of OpenGround, assuming you are using OpenGround. If you're just processing data in RapidCPT, choose whatever units you want. Specify your net area ratio, and then select your files. So I'm going to select 3 CPT soundings with 2 dissipation tests, and an Excel spreadsheet that has our processed P-wave and S-wave velocity data. So you can import as many files as you want at one time and hit Done. And now you can see that the import has completed. So here we see we have 3 CPT soundings that have been loaded in. And if I see these orange buttons here, that means I need to calculate any correlations for these locations. As you can see in this report, the data is not appearing for anything calculated because it hasn't been calculated yet. So if I click these buttons, it will now calculate the data. And if I hit the Save button, it's actually going to save it to the cloud so we can actually see all of those locations have been processed. And when we reload our report, we will see the data there. Okay, so now you see we have our friction ratio, QNet, QT, which are calculated from the raw data. From a reporting perspective, you can change which graphs are shown on each of these different tabs, whether it's the raw data graphs, standard graphs, normalized graphs, soil behavior type graphs, or other graphs, by going to the Reports button. So you can change the maximum scale values. You can change the units. If you want to see certain graphs in different units, you can do that where appropriate. You can hide different plots of the secondary U2 or U0. You can choose which SU correlations you want to see, etc. So that applies for each of these different reports. Choose which graphs you want. Normalized plots are showing all the normalized properties, soil behavior types, if you wanted to compare each of the soil behavior types. And then other is really a completely custom report that you can choose which columns of data you want to print. I'm not going to make any changes there, but fundamentally, we can look at the data in each of the tables. So if we click on CPT data, we now see all of those calculated properties have been calculated. So this is fundamentally no different than what you're used to in gINT or HoleBASE. It's just running in a web browser. Your shear wave velocity data, I think I have shear wave velocity in C6, so there we see that. P wave velocity is also in C6. Pore pressure dissipation tests, I think are in C5 maybe, or is it C10? Yep, in C10. So I have 2 pore pressure dissipation tests at different depth intervals. So we can do whichever one we want and see whatever data we need to look at. So the last step is to export our data to OpenGround. And we simply So choose our cloud that we want to work with. Choose our project. And that's the one we want to work with. And confirm it. Now this project has been linked to this project in OpenGround, so if we need to ever send data to it again, it automatically knows, and we literally just click the export button. It's now sending the data to OpenGround. So here we have OpenGround. There is no data at this point. Let's wait until it finishes, and then we'll refresh the data. It took approximately 20-ish seconds to import that data. If we now go back to OpenGround and we reload the data, what we will see is our 3 locations. Let me assign them to be a static cone penetrometer, whatever location type you call it in your cloud. And now if I do a quick log, we'll see exactly the same data we had in RapidCPT in the cloud shown in our OpenGround environment. So we can use the CPT data with our borehole data, our lab testing data, etc.